work with today as we transition our, as we introduce systems of inequalities. You want to buy at least 6 new ringtones from a website, but you cannot spend more than $15. How many premium ringtones and how many top 10 ringtones can you buy? So we're going to figure out the combination of ringtones that we can buy that fits this criteria. We know a few things here. We know that premium ringtones cost $1.50, and we know that the top 10 ringtones cost $3. Could I buy 4 top 10 ringtones and 1 premium ringtone based on this criteria?
Yeah,
Why yes?
because it's less than $15.
Okay, so the 4 top 10 ringtones would be a total of $12.
Mm-hmm.
Good. And then the 1 premium is $1.50. So how much money am I selling? Am I spending? I'm sorry. Yeah, a total of $13.50. So can I buy those ringtones? Does that fit my criteria? Does it?
No. You need 6 songs.
Say again?
Oh, it says 6.
Yeah, you want to buy at least 6. So the problem here is, yes, those ringtones cost me less than $15, but I didn't buy 6 or more. And it said here specifically that I want to buy at least 6. What is a possible combination of ringtones?
3 premium, 4 top
2 premium,
premium.
2 premium,
And
2 premium, which would be
$6.
$3. The premium are $1.50 each.
Oh, yeah.
And then how many top 10?
4.
4 top 10, which would be a total of 12. Does that work? Yeah, that works. $15, but I bought 6 ringtones. Are there any others any other combinations, or is that it? Can you find another one? 4 premium?
Yeah.
How much would that be?
It would be 6.
4 premium would be $6. And then what else?
Two from the top.
2 top 10, which would be $6. Does that work?
Yeah.
Yeah. Are they the only 2?
No.
No. Can you find another one? Just one more.
No.
One more. One more. 5 top 10.
Yes.
If I do 5 top 10, how much am I spending? 15. So does that work? No, because I haven't bought at least 6. So these are the number of premium and top 10 ringtones that I can buy. This first coordinate represents the premium, and the second coordinate represents top 10. 10 premium, 0 top 10. 9 premium, 0 top 10. 8 premium, 0 top 10. And so on. All of these coordinates, represented as the cell phone ringtones, do meet the criteria that I'm buying more than 6, or 6 or more, at least 6. And then I'm spending no more than $15. So what we're going to do now is we're going to work on how this even came to be. And this is a system of linear inequality. So write this down. I know that it is a lot to write, but this is good information here. A system of linear inequalities is made up of 2 or more linear inequalities. So just like when we learned systems of equations was 2 or more equations, a system of linear inequalities is 2 or more inequalities. They are related. Excuse me. Thank you. Now the solution to the system would be the ordered pairs that make both inequalities or all inequalities true. We're going to look at what those look like. The graph of our system is actually the set of points that represent all solutions of the system. So yesterday and the day before we started working with graphing linear inequalities. Today we're going to take it to the next level and we're going to start working with the systems of linear inequalities. As you finish writing, think about what we know about the solutions to a linear inequality and how that might play into the solution of the system. We're going to go through an example of how to create the graphs for a system of linear inequalities, and then after that we're going to identify the solutions of the system of linear inequalities. Hi. It's okay.
You know how you volunteer for 5th period?
Yes.
You might be bumping up to 6th.
Not a problem.
Alright. Thank you.
You're welcome. Does anyone need more time to?
Yeah.
Okay, no problem.
It's kind of random.
Yes.
This is random, but who's your favorite Disney
No.
character?
We can talk about Disney characters after the lesson.
I had to ask.
Anyone still writing?
Yes.
Okay. Okay. We're ready? So let's start with this system of inequalities. We're going to graph both as a system, and we're going to start to take a look at what the solution of our system would be. How would I graph this first line? This first inequality here, y is less than 2x minus 3. We'll do this in red, and we will do the other one in green. Holidays are coming, so we'll make it look real festive. Y is less than 2x minus 3. How do we graph that line? Or that entire inequality?
Well, you could start with the y.
Okay, I can start with the y-intercept. I'm going to start with the boundary line. Using the y-intercept, I can plot that point. What is that point?
-3.
Okay, and then how can I find another point? I can use the slope. What's the slope here? 2. So how do I show that movement? If my slope is 2, what does it mean?
It means that up 2 over 1.
My line is going to increase 2 for every 1x. Every time my x advances, my entire value increases by 2. That's the idea of the up 2 and over 1. Will this line be solid or dashed? How do you know? What does it mean to have a dashed line versus a solid line when it comes to an inequality?
The boundary line.
The line is not, yeah, the line is not part of the solution. It truly is just the boundary. Am I done? I'm good? No, not yet. What else do I need to do? I need to find the solution, right? The difference between an equation, a linear equation, and a linear inequality. The line itself is the solution of a linear equation. But for a linear inequality, it's not the line that's necessarily the solution. That's the boundary. Where is the solution of an inequality? For just the linear inequality, do I have the solution graphed up here yet?
No.
Why not? What don't I have yet?
Second line.
Well, we're still just graphing the first inequality. Are we done graphing that?
We didn't shade.
I didn't shade anything yet. Right? I need to shade the solution set. How do I figure out which side of that boundary line is the solution?
Plug it.
Plug in what?
A point.
I can choose a coordinate on either side of the line to figure out if it is a solution or not. What coordinate would you like to use? You can use the origin. Yeah, that's a great idea. Any coordinate will work. I like the origin because I like it. I like multiplying by 0. 0 is less than 2 times 0 minus 3. Is this true? Is 0 less than negative 3? No. If this is not a solution set, where is my solution set? The other side, yeah. So I'm going to shade this. I'll take that out. I'm going to shade this. Okay, so I have my inequality. Now I need the other one. I'll do that in green. I have some options for graphing this linear inequality. As it is right now, is that in slope-intercept form? No. So I have two options. One, I could put it into slope-intercept form. What would this inequality be in slope-intercept form? What do I do to get it there? What do I have to get? What am I going to isolate if I want to put this in slope-intercept form? I need to isolate the y. So what can I do so that the y remains, but everything else? Yeah, I can subtract 2x from both sides. So this would become y is greater than negative 2x plus 2. You could graph it that way, or if I didn't want to put it into slope-intercept form, how else could I graph it without moving anything around? Just looking at this original inequality, what could I have done to graph it without slope-intercept form? How? Okay.
If you calculate that, the 2 on the right side would be the y-intercept.
So the problem with that is, what if I had an inequality where the y had a coefficient like 5? Now 2 is not the y-intercept.
You have to divide everything by 5.
So then you'd be getting it into slope-intercept form. But I don't have to get this into slope-intercept form. How can I graph a line without changing the equation in any way? What else could I do to graph a line without putting it into slope-intercept form and using the slope and the y-intercept? How else can I graph a line? You don't need a line. You don't need your equation to be in slope-intercept form to graph.
You can just have the point.
How do I find points?
What is that called again? Where you do there it says plug in that.
Plug in. So what are you gonna create?
What is that called? A coordinate?
You can find coordinates. How? Okay, and what would it give me if I plug in values? Like, give me an example.
Like if you plug in a 2.
Now we're working with the boundary line equation here. When we write our boundary line, it's an equation. So this is really what we're trying to graph. If I don't want to put in slope-intercept, I could find coordinates. How do I find coordinates if the equation is in this format?
You try to isolate something?
If you isolate, that would be getting it more to slope-intercept form. But if I don't want to change the equation in any way, how else do I find coordinates? Substitute what?
Numbers, values.
I can substitute in, okay, and what would that give me? Give me an example. You're saying substitute numbers in. Give me an example.
So for x,
If x is 1, what's y? You sure? If x is 1, y is 0. Do you have another one?
0.
If x is 0,
Y is 2.
y would be 2. So what are you creating?
a table.
Yeah, you can create a table of values. Right? You can always create a table of values if you need to create a line. So for those of you that struggle to get an equation or even an inequality into slope-intercept form, you don't need to. Or you can still graph it this way. Because now I can plot these 2 points. where x is 1 and y is 0 is here, where x is 0, y is 2. But notice, if I wanted to plot this y-intercept of positive 2, that would be here, which I've already plotted. And then my slope of negative 2 means for every 1x, I'm going to go down 2. That is my line. I can do it both ways. Will this inequality be a solid line or dashed line? Am I done? No, I still need the solution set. How do I find the solution set here? Just talking about this one inequality, where do I find the solution, or how do I find the solution of the inequality that we're graphing? Yeah, I can plug in a coordinate. Choose a coordinate. Which one would you like to do? The origin works. What's going to happen if I substitute in a 0 for x and a 0 for y? What's that entire side? 0. Is 0 greater than 2? No, so this is not in my solution set. So what do I shade? Yep, the other side. What do you notice? Christmas. Yes. What do you notice about the two? Now this is, we did graph two inequalities onto the same graph. We've graphed a system. What do you notice about their solutions?
They overlap.
Okay, so what is this area? I'm actually just going to combine a few of the next slides together. What does this area represent?
The solution to only work for the balloon.
This is a solution that represents only this inequality. And then down here, I'll use the simple one. What about this?
Solution to inequality.
That's a solution set. That part is only a solution for the red. What about here?
Solutions for both of them.
What do you notice about the colors?
Yeah.
They're together, yeah, they overlap. This area represents the solution set of the system. And why is that the solution set for the system? The solution for our system, as you just wrote down, would be the ordered pairs, or the coordinates, that are true for both inequalities. So a point in here, for example, like where x is 8 and y is 0. Let's check that. Does that work? If x is 8 and y is 0, let's try it here. Y is 0, 2 times 8, and then if x is 8 and y is 0. Are these true? Is that top inequality true? Is 0, what is this term on the right side? 2 times 8 minus 3. 13. Is 0 less than 13? Yes.
Yeah.
So that's a solution for the one inequality. How about the bottom inequality?
16.
Is 16 greater than 2?
Yeah.
Yes. So because this coordinate is a solution for both, it falls within the solution set. I like systems of inequalities because they're very colorful. Now, as we slide through, some of this stuff we've already talked about, but I'm going to slide here. Okay. This is actually just the image from the textbook for those of you that had a hard time checking my color out. And just to recap here, this section, this top blue section represented the solution. It was only a solution for this inequality. This bottom section here is a solution for just the other inequality. This section together is a solution set that they share. Okay, so when we graph these inequalities, kind of taking it to the next level from where we were yesterday, we're trying to find, just as you wrote down in your notes, the coordinates, the ordered pairs, the range that both inequalities share as a solution. Heads off the desk. Now, if we needed to check it, which we already did, but this is the breakdown of how you would check it, you can check in both. As you get to real-world inequalities, you'll have more examples of this. Think about the first problem that we did with the ringtones. you could actually have graphed those two inequalities and found that the ringtones that we said would work, would fit both criteria, less than $15 but more than 6 ringtones, those coordinates would have fallen in that shaded area that they share. We're going to try one. Are you ready to try one? Are you ready to try one? No?
No.
What do you want to go through? You want to go over another one? Okay. Why don't we do the next one together then? Okay. So let's do this one together. I'm actually going to pause here since we'll take a little bit more time.